Okay, so today we'll be discussing about how the internet works. The internet, we know, is a connection of so many systems, so many machines, so many computers. Then all these computers are connected to different servers. So these servers are where we store information. So informations are stored in the servers, and the information are stored in different servers, and they are all interconnected. So this way, we have a network of different systems connected together. So right here in the definition, we say the internet is a system with two main components. Two main components. We have the hardware and the software component. The hardware includes everything from the cables that carry terabits of information every second to the computer, to the devices which are used, called the clients. So the devices which we use to connect to this internet is are what we call the clients. So
All right, sir. Thank you. Tomorrow.
so these devices are called the clients. Now, other hardware that supports the internet includes we have the router, servers, the cell phone towers, satellites, radio, smartphones, and every other devices. So we know that cell phones do not actually fiber optic cables that are used to connect the internet. We can't connect them to our cell phones. Then, if that is on, we wouldn't be carrying this. They wouldn't be mobile. The phones wouldn't be mobile. So in order to get a mobile phone, we had the idea of the cell phone towers. The fiber optic cables are now connected to the cell phone towers, and from the cell phone towers, a signal is being sent through the satellite down to our phones. That's how we connect to the cell phone towers, and that's how we have these mobile devices on them. They are very easy to use. Now, all these devices here are mostly the devices called mostly the client devices. Now, these together, all these devices create a network of networks. The internet changes in little way as elements join and leave the networks. Some of these networks may stay fairly static and make up the backbone of the internet. Some of these elements are called endpoint clients. Example, we have our phones, the computer, whatever devices we use to access the internet. These are called what? Endpoint clients. So we call them the client servers. So the endpoint clients. So we have other elements, the nodes. They serve as the connecting points along the routes of traffic. So we have different endpoint clients on display. When you connect your laptop or your phones to the internet, they are used as what? Endpoint clients. So, all right. Now, we look at the fiber optic cables. How was this? Firstly, the first set of cables installed connected United States to the UK. Now, you look at these fiber optics cables. What are they? The internet we see, logically, it is very easy to think that the internet we see, the internet we are having access to is mostly in the cloud. We have the cloud base, and then we get from satellites, we get networks and the servers and everything. No, that's not how it happens. The major theory there is that these are cables submerged in the ocean, and then most of them go through very difficult terrains, some of them through the mountains, some of them through valleys, oceans, underground, everywhere. Now, mostly submerged in the what? Ocean, connecting what? Countries, connecting what? Continents. So these cables send signal through what we call light signal. They transfer light waves. So we say transmission lines, which can be physical, as in the case of cables and fiber optics. The protocols are set of rules the machines must follow to complete tasks. They provide both the method and the common languages for the machines to use while transmitting the data. Now, here we have on display are some examples of some fiber optics cables. So we have the deep water coaxial telephone designs that we have first presented. We have the copy of the 1963, the one of the 1970, the 1976, and much more sophisticated designs we have now. How are these cables coated? Because of the difficulty they experience, and some of them experience shark attacks, and so these cables are really protected with armored bodies. Some of them are unarmored deep ocean cable. We have the armored cables, and then these now cables are connected to what the terminal equipments, and then we have the networks being managed. All right, types of fiber optics cables. We have different types of fiber optics cables. For the first one on our list is the single mode fiber optics cable. This type of cable has a very small core, which allows for the transmission of light over long distances without attenuation. Single mode fiber optics cables are commonly used in long-haul networks, such as those that connect cities and continents. So when we are looking at connecting long networks, we use a single mode fiber optics cable. So you remember, like I said in the previous slide, that the networks, the interconnection of networks, the whole internet system is being transmitted by cables. We're running a cable system actually. Yes, the question would come up like, I'm using the my phone and I'm using my laptop devices. I don't have any cables connected to them. This is as a result of the word cell phone towers. So these cables connect cities to cities, countries to countries, ocean, continents to continents through what? The ocean. Now, next we have is the multi-mode fiber optic cable. This type of cable has a larger core than single-mode fiber optics cable, which allows for the transmission of multiple light beams. Remember, I told you that these networks, these messages we send through the internet are transferred as what? Light beams at the same time. Now, the multi-mode fiber optics cable are commonly used in local area networks and metropolitan area networks. So when we start looking at the different types of network, we have LAN, local area networks, metropolitan area networks, and then other forms of networks. Then we have the patch cord. The patch cord is a short length of fiber optics cable that is used to connect two devices, such as a router and the switch. So now we are done with the deep water connections, then the offshore connections. Now we are looking at these connections are further extended to our different homes. Now at our different homes, we use the patch cords, which are used mostly to connect two devices such as the router and the switch. The patch cord cables are available in single mode and also in multi-mode varieties. Now we have the final one, the connectors. A connector is a device that is used to join two fiber optics cables together. There are many different types of fiber optics connectors, each with its own advantages and disadvantages. To have the different types of connectors and having different advantages. Now we look at the protocol. How is all these? Look, the phones, the computers, your PC, your desktop, everything connects to the internet, then to a server. Now networks, everything you send is transferred through a protocol. We have the protocol we have the IP, the internet protocol. You mostly hear about this IP address. Each system, my phone here has its own unique IP address. The laptop has its own unique IP address. Your PC has its own unique IP address. Every device you have that connects to the internet has its own unique IP address. The IP address, IP for internet protocol address, the internet protocol address serves as a unique way to connect the system or the phone or the device to the server and sends back a response uniquely, directly like many people might send off a request at the same time, but you get your own particular request. Let me say 2 people sitting at the same place next to each other. One searches about a food restaurant, the other person searches about a fancy store restaurant. Now, the person searching for a fancy store restaurant and the person searching for a food restaurant are using the same network provider, the same internet network provider, internet service provider, and the same ISP. Yet they get uniquely different responses. Why is that so? Their different response is as a result of what? Their IP address. You can't get the IP, you can't get for your own IP address a response for someone else's what request. Is not done so. So the first protocol on our list is the HTTP. We have the hypertext transfer protocol. And we know HTTP and HTTPS, hypertext transfer protocol, and hypertext transfer protocol secure. This is a protocol used to view websites through a browser. Now you have your website or web pages, you want to view them through a browser, you need a protocol. You connect to that protocol, which is in a server. You send your request, it brings out those information for you. Next, we have the file transfer protocol, FTP. The FTP, the file transfer protocol, is used to transfer files from one device to another. These protocols create frameworks within which all the devices must operate to be part of the internet. Next, we have the VoIP, the Voice over Internet Protocol. This protocol converts internet cell phone calls into packets. Remember, whenever we send out requests to the internet, these responses are gotten back in packets, and as they get back to us, these packets are constituted into a complete information. Now, the 2 most important protocols we have are the TCP and the IP. Remember, I've said in the last slide about the IP, the Internet Protocol. The TCP is a transmission control protocol, and the IP is the Internet Protocol. Each device, I said it previously, connected to the internet has a unique IP address. And this is how one machine can find another machine through the massive network. We have a lot of networks, a lot of computers, a lot of machines connected to this network. Now, one machine can find uniquely another machine through the IP address. Now, here currently we use the IPv4 version 4 of the IP, and this version was based on the 32-bit address system. Now, due to the increase in users, the version was now further modified, and we have a newer version called the IPv6 with a 128-bit address system, and that was created. We'll see what we call the TCP/IP. This helps to make transmissions of information from one machine to the other possible. Now, on the TCP/IP model, we have for applications, we have HTTPS, TLS, and DNS. Now, what do we mean? What is DNS? Domain name server. So each web page you visit on the internet belongs to a particular server. So for you to be able to access that server, you must have to hit the domain name server. Like domain name server, we have facebook.com. When you hit the DNS, then you can now fetch informations in that from that server. So we have the transport TCP UDP internet, we have IPv version 4 and IPv6. Then we also have the networks, the Ethernet, wireless, and LAN. Now, furthermore, the transmission control protocol, the TCP, and Internet Protocol, is a suite of communication protocols. It encompasses the set of rules and procedures used to interconnect different network devices over the internet. These protocols define the mechanism for transmitting, routing, dividing data into packets, Remember, I told you that data is divided into what? Packets. And these different packets are what's sent and then extracted. These different packets are sent and then what? Extracted. When you send an information requesting for a particular data, it is divided into packets for quick transfer. Now, these packets come over to you and then is being assembled at your own end. The packets addressing and receiving data at the intended destination. The TCP defines how applications can create communication channels across network. The IP defines most uniquely and identifies most uniquely the client who is visiting the server, while the TCP defines how the applications can create communication channels across the networks. IP defines each packet's addressing and routing mechanism to ensure it reaches the intended destination. So to finalize this is the model of how this information transfers. When you send a request, it must hit the domain name server along the way. Once this target receives the request, the data might travel a completely different path to get back to you. It mustn't have a straight line pattern. No, it must travel a completely different path, either through part A or part B or part C, whatever part it does, it just does travel to, it definitely must get to you because it identifies with you and you alone. That's just like sending a mail address and you have your mail, you send a mail through the mail providing the mail server, the mail company. Now, if you don't address your mail properly, you notice that you might have a missing response. If you mail, your mail might not get to the destination. Let's say I live number 7 New Jerusalem Estate and I'm sending a mail to someone who lives 10B Flight Chicago downtown. So if I don't address that mail properly, it will be very difficult for the mail transmitting company to transfer my mail to its destination. And because of through this with this being experienced, there will be problem sending and delivering the message. Remember, what's the essence of the internet? To send and receive information as quickly as possible. That goal, that objective would be breached if there is no proper mailing system or mail addressing system. The IP address takes care of this mail addressing system, making sure that your data, your details, your information is uniquely sent, and then you don't get another information. It might be I sent an information requesting to view a particular page, and someone else sends an information requesting to view a different page. I can't get the response from the internet relating to the other person's information because I have a unique IP address. So with this, I think we've been able to explain to you very well how the internet works. So I'll look at it and expect you to respond to you at the comment section. Thank you.